Hi, this is going to be a video on graphing the logs. I'm going to review different ways to graph logs. One way is doing it by converting the exponential form. One way by doing transformations to the parent function. One way is to just stop complaining and plug in points and make it happen. And you can also do it in your calculator. Remember at all times, as always, that logs are exponents and that logs are inverses of exponents. Two ideas that I come to a lot. We start by just graphing y equals 3 dx. This is actually an exponential graph, not a log graph. That's okay. I can just plug in powers or numbers for x. When it's exponential, you're just going to go for it. 3 to the negative 1 is a third. 3 to the 0 is 1. 3 to the first is 3. And 3 to the second is 9. So I have negative 1 a third, 0, 1, 1, 3, and 2, 9 will be way up here. And the graph goes like this. Didn't graph that super well. I want to try to make it a little better. Sure. This has an asymptote at the value y equals 0. It has a domain of all real numbers and a range of y such that y is greater than 0. Because the range of an exponential is always related to the asymptote. Now remember, the inverse of an exponential is a logarithmic. If I have log base 3 of x as my function, these are inverses. Inverses means you're just switching the x and y values. So if I make a table of values of what to plug in for x here, I want to plug in powers of the base. Powers of 3. Well, 3 to the negative 1 is a third. I'll plug that in for x. 3 to the 0 is 1. I'll plug that in for x. 3 to the first is 3. And 3 to the second is 9. These are the numbers I want to plug in for x. Third, 1, 3, and 9, which just come from this column over here. But now if I think about doing log base 3 of 9, which I could actually write like this if this helps you at all, I'm really doing, I can calculate this value. This is just some number. So I'm doing 3 to the something equals 9. In this case, we call that something y. 3 to the y equals 9. So y equals 2. And this is the point 3, 2. And this would be the point 1, 1. And this would be the point, oops, sorry, I have these off. The point 3, 2 is here. So it's the point 9, 9, 2, 3, 1, 1, 0, 1 third, negative 1. I hope you notice that all those y values are coming from these powers, because the logarithm is the exponent. The exponent is really what the log is equal to. The log is the exponent. And I hope you notice that these are all just switched. The point negative 1, 1 third becomes the point 1 third, negative 1. 0, 1 becomes 1, 0. 1, 3 becomes 3, 1. 2, 9 becomes 9, 2. Because these are just inverses, and inverses switch the points x and y. So I have the point 1 third, negative 1. I have the point 1, 0. 3, 1. 9, 2 is way out here. This graph goes like this. It has a vertical asymptote at x equals 0. The domain is x such that x is greater than 0. And the range is all real numbers. On all logarithms, the range is all real numbers, and the domain is based on where the asymptote is. And remember that all inverses are just reflections over the line y equals x. Or we switch x and y, and that's what we have here. Okay? Basic logarithm review. Now let's graph one. Take an equation that's about as bad as I can make it. I suppose I could have made this a negative 2, but other than that, this is about as bad as it gets. I'm going to graph it by converting to exponential form, meaning I want to get out of log form into exponential form. So I'm going to get this by itself. First thing I do is add 1. Then I divide everything by 2. Then I get y plus 1 over 2 equals log base 3 of x plus 4. Now that the log is all by itself, I can convert. So I do 3 to the y plus 1 over 2 equals x plus 4. subtracted 4 from both sides, and I've converted this to fully exponential form. The problem is, the x is by itself, not the y. That's actually not an issue, only now I'm just going to plug things in for y instead of x. I want to be smarter than the problem. I want to plug in smart numbers for y that will make this come out to a whole number, which in this case is pretty straightforward. I just need to plug in numbers that are odd, because an odd number plus 1 becomes even, and even divided by 2 is also going to be even. So I'm going to plug in odd numbers. I can plug in numbers like -3, -1, 1, 3. Plug these numbers in for y. Make my pen a little smaller. So let me do this one first. I'm going to plug in -3 in for y. It's -3 plus 1 is -2, divided by 2 is -1. So it's 3 to -1 minus 4 equals x, which really means that 1/3 minus 4 equals x, which is -3 2/3. Now I'll plug in -1. 3 to -1 plus 1 divided by 2 minus 4 is really 3 to the 0 minus 4, which is 1 minus 4, which is -3. This is the point, -3, -1. I plug in a 1, I get -1. Plug in a 3, I get 5. So I have the points -3 2/3, comma -3, -3, -1, -1, 1, and 5, 3. This graph is going to have a vertical asymptote here, which means that it's going to look like this. And that's pretty good. Domain x such that x is greater than -4, so it will always come from this value right here. Range, always all real numbers with logarithms, and the asymptote was the line x equals -4, which is always going to be the same as that over there. So that's graphing by going into exponential form. Just get the log by itself. The stuff in parentheses all stays together. Get that by itself, and then convert out of that form. That's different for y. Second way is by doing transformations to the parent function. Here the parent function is y equals log base 3 of x, which we've already graphed, but let's just do it again. I'm sorry, I don't want to plug those in for x. I want to plug those in for y, basically, but I want to plug powers of 3 in for x. So I want to plug in like 1/3 is really 3 to -1. 1 is 3 to the 0. 3 is 3 to the first. And 9 is 3 to the second. If you're not sure how I did that, I did the same problem earlier in the video, so you can go back and watch that. Well, this moves everything to the left 4. And moving everything to the left 4 really means that I can subtract 4 from all these x values. And I actually end up with -3 2/3, -3, -1, and 5. This doubles all the y values, and this subtracts 1 from all the y values. Pause now. So this looks kind of messy. It's -3 2/3, -3, -1, and 5. That's probably worth 5.
Dr. McCool, please come down to the front office. Lee Jackson, please come down to the front office as well.
Now all the y values are going to get doubled.
And the robotics team is having a meeting today. Thank you.
And then have 1 added to them. So that becomes -1 times 2 is -2, plus 1 is -1. This becomes a point. That's a 1, and that's a 3, and that's a 5. And I graph these points. -3 2/3, -1, -3, 1. These all should have been -1s, excuse me.
Yes, and the robotics team is going to have a meeting after school in the robotics room. Sorry about that.
So this goes -3, -1, 1, 3. So I have the point -3 2/3, -3, -3, -1, -1, 1, 5. Hopefully this graph is very similar to this graph, and the curves just a little bit off. But they have all the same points, which is definitely a good thing because they're the same line, same graph. So this changes the x values, this doubles the y values, and then subtracts 1. It has to go in that order. Times 2 minus 1, times 2 minus 1. The third way, this is probably the most difficult way to really understand, but it actually makes the easiest way to do, is to get smart about what points I plug in for x. I want to plug in points for x that make this powers of 3. Plug in points for x that make this a power of 3. So I really want x plus 4 to come out to something like a third, or 1, or 3, or 9, because that's 3 to the -1, 3 to the 0, 3 to the first, and 3 to the second, power to 3. If I subtract 4 from everywhere, 1/3 minus 4 is really -2 2/3. 1 minus 4 is -3. 3 minus 4 is -1. And then 9 minus 4 is 5. So those are the points I'm going to plug in for x. Now this got really messy, but these are going like this. So I have -2 2/3, -3, -1, +5. Should be +5 there. That's what I plug in for x. Well, now when I plug those numbers in for x, I'm like literally going to do 2 log base 3 of, I'll plug in this one first, 5 plus 4 minus 1. But I already know what this is going to come out to. This is going to come out to this, because the log is the exponent. So this really becomes 2 times 2 minus 1, which is 3. And this will become 2 times 1, which is 2, minus 1, which is 1. And this will become 2 times 0, which is 0, minus 1, which is -1. And this would be a -3, because these y values should always follow the pattern of whatever this a value is. This a value is 2, and these all go up 2. So my graph is going to have -1, 2 1/3, -3, -3, -1. This is -3, 2. No, wait, hold on. -3 2/3, excuse me. Like this. And the point -3, -1, and the point -1, 1, and the point 5, 3. And kaboom. This graph looks like this graph, just like this graph, because they're all the same equation. Okay, that's just plugging in points for x that are smart. Points that will make this come out to powers of 3 once they have 4 added to them. And you have to subtract the 4, so when you plug this in, you're going to add 4. You basically want the 4 and the -4 to cancel to get you out powers of 3. Finally, I'll show this once really briefly. Your calculator can maybe handle how to do this without the change of base formula. And if it can, great. But if it can't, either way, you can work this way. The change of base formula is if you have log base b of a, that's really log of a divided by log of b. I'm going to use that here. So in my y equals menu, I'm going to do 2 times the log of, in parentheses, x plus 4, close parentheses, divided by the log of 3, close parentheses, minus 1. That's the way you type in this action over here. That's the correct way to type that in using the change of base formula. I took this part here and I changed its base. Now when I graph it, there's my equation. It's going to stop here because your calculator can't show a vertical line. It doesn't graph vertical lines and it doesn't show the whole asymptote. So you have to understand the curve actually goes all the way down forever. If on quizzes and tests you don't show me the whole line, I will take out points. And now you can also pull up your table and look at how these points we had before are the same. There's our -3, -1, there's a -1, 1, And then we have 5, 3 somewhere. Yeah, there's your point, 5, 3. So, here's your graph. Thanks, hope that was helpful.